Okay, second part of this binomial products video is got to do with special products, perfect squares, and difference of two squares, which you may or may not have touched on in Year 9. Look, okay, there's a special trick to this, which I'm going to show you. First of all, what I wanted to say was you can expand these just as normal using the FOIL method. So for the example, this one, 3 minus root 5 squared is equivalent to this. Okay, so this expression times itself. Okay, so you could multiply these out quite happily, and you get your answer. Okay, just like we did in the previous one. Now, depending on how you were taught last year, there is a trick to doing perfect squares and difference of two squares. It's not a trick; it's more of a shortcut that we can use when we recognize a perfect square. Now, that trick was so when we are multiplying by the same thing. So perfect squares, we can, first of all, we'll end up with 3 terms. Okay, so the first term, yeah, so you'll end up with 3 terms. I won't go through the FOIL method because hopefully you can do that on your own. But if you use the perfect square method, you'll end up with 3 terms. The first term will be the square of this term here. In other words, 3 squared, okay, which will be 9. I'll leave it like that for the time being. I'll do the last one because the last one will be so what you do is you square this last term. All right, so the square of root 5 is going to be 5. Okay, so I think that's pretty straightforward. Actually, I'll write that in there like that, and we can simplify it in the next line. Now, the middle term is the trickiest. Okay, and it's not always obvious why you do this, but to find the middle term, you multiply this first number by this second one, and you times by 2. Okay, so writing that out, you get, so plus 3 times root 5 times 2. That will give you the middle term. Okay, so in this case, let's simplify that. 3 square root of 3, sorry, the square of 3 is 9. Now 3 times 2 is 6, times negative 1 is negative 6, and we've got a root 5 there too. Okay, and finally we've got our plus square root of 5 squared is just 5. Okay, so bringing that all together, 9 plus 5 is 14, and then we have our minus 6 root 5. Okay, so we have, it's a little bit tricky, a little bit harder to get your head around to do it the special products way. Yeah, but it's worthwhile because once you can identify the perfect square rule, it does help you speed up your maths in the future. And when we come to going backwards, so doing the reverse operation, yeah, it's actually essential. Okay, so try and pick up this way of doing it. So let's do the second one here. Again, it's the first term squared, so 2 root 3 all squared. Okay, I'll do the last one, the last term squared, so 3 root 5 all squared, and then, so that's that one. And then to get the middle term, you multiply. Okay, so it's 2 times 2 root 3 times 3 root 5. Okay, so it's getting a bit complicated now. Now with this 2 root 3 squared, you have to square all the numbers in there. So 2 squared is 4, and root 3 squared is just 3. Okay, again, 2 times 2 root 3 is 4. So we're timesing the coefficients here. 2, 2, and 3 are the coefficients. So that becomes 2 times 2 is 4, 4 times 3 is 12. And then our surds multiply together as well. So root 3 times root 5 is going to be root 15. Okay, and finally, at the end, we've got our 3 root 5 all squared. Again, 3 squared is 9. Root 5 squared is just 5. Okay, so simplifying that down, we get 12 plus 12 root 15 plus 45. Okay, adding our constants together, we get 12 plus 45, which is 57, plus 12 root 15. Okay, so that's how to do a perfect square expansion. Okay, so looking down to these difference of two squares. Okay, now these they look a bit trickier, but they're actually a little bit easier, because when you multiply these out by FOIL, normally you get four terms if you multiply this out the longhand way. What will actually happen, because you've got a plus here and a minus here in exactly the same expression, okay, the two middle terms cancel out. So what we can do with a difference of two squares, and I'll show you why it's called that in a minute. So when you have two brackets exactly the same numbers in them, but with a plus and minus multiplied together, it's called a difference of two squares, and the middle two terms actually cancel out. So all we need to do is going to be two terms in the end expression. The first one is going to be the square root of, the square of this number, okay, minus the square of this number, okay. So let me show you how that works. It's going to be 3 squared minus root 2 all squared. Okay, so in this case, 3 squared is 9, minus the square root of 2 all squared is just 2. Okay, and that becomes, okay, we've got no more surds now, so that becomes 7. Okay, so let's do that again. So example F, okay, it's a difference of two squares. The two expressions are exactly the same, except there's a minus and a plus here, okay, which means that it's difference of two square numbers. All right, so we don't need to use FOIL. We can simply go, it's the 5 root 2 all squared minus root 3 all squared. Okay, difference. This is why it's called a difference of two squares, because you've got two square numbers. There's a square there and a square number there, and there's a difference in between them. Okay, so it has a special way of factorizing. So 5 root 2 squared. Okay, 5 squared is 25. Root 2 times root 2 is just 2. Okay, take away this expression here. So the root 3 squared is just 3. Okay, because that's quite easy there. So 25 times 2 is 50 minus 3 equals 47. Okay, so that's how you expand perfect squares and difference of two squares. Have a go at some problems. Thanks for watching.